Cool. All right. Let's play this game. Excellent. Hello, everybody. Are you all awake after lunch? Yeah, I find I have to do that in case people fall asleep. My name's Mark Mandel. I'm a developer advocate for Google Cloud Platform. One thing you will definitely notice about me is during this talk, my accent is going to slip from Australian to American and back to Australian and back to American. So it'll be hilarious for all of you, I should say. I do a fun job at Google, basically around Google Cloud Platform, where I am the receptacle of all your complaints. But at the same time, they pay me to come out and speak to you and do conferences like this at the same time. So, you know, pros and cons. I want to talk to you today about scaling multiplayer games with open source, which is fun. Yes, as I speak more, I can hear my American accent coming out. That's what I'm used to. Before we get started, I do want to say my business cards are up the front, along with a whole bunch of stickers and all that kind of stuff too. So if you don't get a chance to ask me a question during the session, for whatever reason we don't have time or you don't think of it, please grab a card, feel free to send me an email, DMs on Twitter are open, more than happy to chat with you. Again, also at the conference, I'm here at PAX as well. So yeah, all that stuff is there. I'll remind you, all the code for this is open source, it's on GitHub, there are links at the end. Yeah, so if you have any questions or anything like that, more than happy to field them. Awesome. All right, let's play this game. All right, so that's a little bit about me. Before I get stuck in, I'd love to know a little bit about you, so I can sort of tailor the content a little bit. So this is a technical talk, so people here are technical programmers. Sweet, excellent, good. This is very much like a how-to, and I'm going to show some code and that kind of stuff. People who work on multiplayer games currently? Sweet. People who want to work on multiplayer games? Sweet. All right, that's good. Then you are my audience. Fantastic. All right, people here who like sushi? I don't know. That was just a random question to see if I can make you put your hands up. Excellent. Okay, so what do I want to talk to you about today? I want to talk to you about how I'm a terrible game designer and terrible artist. I created a very, very bad game because I wanted to basically play with server infrastructure. So I made this game in Unity. Like I said, it's all open source. You can totally play with it. It is called Paddle Soccer very creatively in that it involves two paddles that play soccer. It is a two-player online multiplayer game. So it's a session-based game. Two people connect to a matchmaker, and they end up playing this game together, and they score goals, and then they lose. It's basically Rocket League, but without the cars or the rockets or the league, because it has a half dome and a ball. It's fine. Like I said, I make terrible, terrible games just so that I can be like, oh, look, now 1 million people can play this game. It's fine. It's all built with Unity. There's a Unity dedicated server that we'll talk about in a bit, Unity clients. So that's kind of basically the general gist. So what I want to talk to you about today, and there's all sorts of stuff we could talk about with like backends for multiplayer games and that kind of thing, but I want to talk about sort of the sort of games that are like session-based games. So we're talking like your Overwatches, your Unreal Tournaments, that kind of fun stuff. Basically, and what I want to talk to them about them in an environment where you have an authoritative server, right? So you have some kind of simulation server that lives somewhere on the internet, or quote unquote the cloud, if you want to use that term. Wherein that authoritative server is essentially your source of truth, right? So you may have a multitude of players who end up connecting directly to a particular server, which is like the process that represents your game, and they have information that comes in, and the server basically spits back out exactly what should be happening in the game. The way I like to think about this is basically the client is the one that asks, right? Hey, I want to move forward. Hey, I'm going to shoot the thing. Hey, I'm going to kick a ball. And it's the authoritative game server's job to basically tell, this is the ultimate truth. This is what actually happened in the game. This person moved from here to here. Because unfortunately, people are horrible, and they like to hack your games. And that's just the reality of the situation. If you're at all interested on the Unity side of things, just for interest's sake, if nothing else, this is all basically prototyped using Unity's high-level API, which means I don't have to write my own UDP protocols because that's boring and I don't feel like doing it. Actually, it's really interesting, but I just don't feel like doing it. And on top of that, if you've ever played with it at all, Unity has the ability to make Linux headless builds. And that's really tiny. But if you could see really small, there is a checkbox there that says headless build when you try and build a Linux version. The nice thing about that is it doesn't need a display or a GPU to run or anything like that. So you can run reasonably okay-ish dedicated game servers with it. And they have sort of a framework to help you kind of do that and, excuse me, and sync data and state between those. I'm not going to dig too much in those. Just I want you to know that that exists, and that's basically how we made all this stuff happen. You can see that there. Cool. So let's talk more about architecture and how this stuff kind of works from a more architectural point of view. So this is kind of the setup of what you would probably see in a lot of your normal or everyday kind of multiplayer session-based games. If you're not familiar, that's good, because we'll go through it. So basically, you'll have, in this case, 2 players, but it may be more, who will end up connecting to some kind of matchmaker. So the matchmaker's job is to basically to pair groups of people together. Usually they have some skill-based ranking and other fun stuff, which is totally fine. Once they have a group of players that are joined together, they usually then talk to some kind of server manager, right? This is the job to start up a process for these people to connect to and like play on and that kind of stuff. And the job of the server manager is usually then to talk to some probably very large pool of actual physical machines or virtual machines to start up this process, get all the details of it, find out the IP, find out the port, that kind of stuff, so that they can send all that information back up through the matchmaker to the 2 players who want to play the game, and they can make a direct IP and port connection to the player, to that dedicated game server, and they can play a game. Right? And this is pretty much what all of us do when we play Overwatch. If you play Overwatch or any of those sort of games, that's pretty much it. Cool, that all sounds pretty standard-ish. We're all getting some nods. Sweet. Excellent. Okay, so we have a sort of standard. So what I want to talk about is how we can take this kind of architecture and build this out without having to do all the work ourselves, because doing everything from scratch sucks. And there's a lot of work out there that makes this stuff a lot easier. So I want to start with this funny logo thing. All right, so who here has worked with Docker before? Oh, quite a few of you. Excellent. Not all of you, so that's fine. Docker is really cool tech. It's something I get really kind of actually excited about. And the reason I get excited about it is because Docker gives you a way to basically wrap up your software in what we commonly refer to as a container in such a way is that it abstracts away exactly the specific nuances of how your software runs. So like, which Linux operating system are you running on? Which binary does it start with? And once you kind of do that, that means really powerful things start to happen. So we'll kind of step through this bit by bit for those of you who aren't as familiar. And the analogy I like to use is very much like the shipping container. Because I think it actually works really well. So in this case, we have this like dedicated game server written in Unity that has its own nuances about how it does stuff. But what it means is we can put it inside a container, right? Hence my metaphor. And if you think about the shipping industry and how that works, the shipping container was actually really revolutionary. Reason being that at the end of the day, it doesn't actually matter what's inside that shipping container. You could have a Ferrari in there. You could have, I don't know, half a tree. You could have a group of alligators. Like, it actually doesn't matter. Because at the end of the day, once you have a shipping container, that means that all the cranes, they all work the same. All the ships, they all work the same. All the forklifts that take these things on and off, it all works the same. You have this standard abstraction that means that all the solutions for the stuff you want to do with a container are easily able to be produced. Lots of different competitors can do lots of cool stuff with it. And it's all the standard stuff that you would need to be able to do. So this is why I get really excited about Docker containers, because they give us a way to abstract, like, you know, the Ferraris of whatever else you want to put inside your software. But it means then we can build these generic solutions on top of that abstraction to say, oh, I need to deploy a new version. Oh, I need to actually start this thing up. Oh, I need to stop it. Oh, I need to run this over 10,000 machines. And that kind of stuff is super cool. So we'll look into that in a minute. If you're not familiar with Docker, I'm just going to step you through basically how you actually do this most of the time. So if you want to create what's called a Docker image, which is this artifact that you end up passing around, you write this thing called a Docker file, strangely enough. It's pretty explicit in how it works. It just goes top to bottom. So you would say, okay, where's my from? Like usually what operating system or base image do I want to start from? So here I'm starting from Ubuntu 16.04. I've got a process that takes my Unity server and tars it up, so it puts it in an archive. So I copy that in, I untar it. Entry point is just a nice way of saying when this image gets created and then run, this is the thing I want you to run. That's it. So I've literally just copied in this binary with a bunch of assets, and I'm like, hey, spit that out the other side for me, please. And then I can go Docker build, and it will spit out an image. So the other nice thing about this as well is you have this workflow process. So we wrote this Docker file, we get this image, we're able to give it what's called a tag, which means we have a name for it. This also means that we can version our images, which is also really nice. Again, something we don't have to do. Here I'm saying this is sucker server 0.1. And we also have this other common thing called a repository, where this is the place in which we share these images. So if you're like, oh, I need a secure way of shifting these things around either between machines or between teammates and stuff like that, repository is a thing that's built for you, has authentication, that kind of stuff. Here I'm using, well, for obvious reasons, I work for Google Cloud. I'm using our private container repository. You could use Quay, you could use Docker Hub, there's a bunch of them. But again, it just means I don't have to build something to shift this stuff around. The security's built in, right? There's all the checking to make sure it's a valid image. Should I have access, should I not? But again, once I have my image, I can put it in my repository. It's able to be shared. So we'll have a look. Let's see if stuff works. It's not that screen. It's that screen. All right, cool. So this is, I've pre-compiled everything. It's all ready to go. Oh, I have it up here. I can do this. So here's me starting my server. All right, it looks pretty much like a bunch of output. Big deal. All right, we'll cancel that. But what I can do, yes, that's actually correct, is I call docker run. And it does exactly the same thing, which on its surface doesn't seem that interesting. But the thing that is actually interesting is the fact that I said docker run. Right? We talk about that abstraction, that container. This means that no matter if I'm running this dedicated game server, or maybe I'm running a matchmaker, or maybe I'm running some back-end process that manages my player inventory or a marketplace or anything like that, it's all the same. And as long as my output goes to like the standard out, which is this here, which is where you see that -log file, which just makes Unity do that. That's basically the standard spot for logs. Like, I can do some really amazing things. I can take those logs and do stuff with them too. Like, that's really the only thing I need to worry about. So that's pretty cool. So that's like the basic level of Docker. Cool? Sweet. All right. Fantastic. So, all right, so we have this dedicated game server. It's cool. We can connect our game to it. We can have players. They do stuff. Awesome. But this is just one dedicated game server, right? We just saw one container running. That's not that exciting. What we really want to do is have it so that we can have lots of people play our game, because every game we're all making is going to be amazing, right? And everyone is going to want to play it. Yes. Excellent. Okay. So this is where we get into this weirdly named thing. Who here has played with Kubernetes, used Kubernetes? Not that many people have heard of Kubernetes? I say Kubernetes. Some people say Kubernetes. Technically, it comes from the Greek word helmsman. So if there's anyone who speaks Greek, you can probably correct my pronunciation in some way, shape, or form. So Kubernetes, another open source project that its job is essentially to orchestrate these containers at scale over hundreds, potentially thousands of machines. It's an open source project started at Google, has had a huge amount of input from a variety of other companies, including Red Hat. I'm probably going to get some of these wrong, but Red Hat definitely. Target's put in stuff. Microsoft's doing stuff in it now. It's running in eBay. It's running in, if you ever use GitHub, you've used Kubernetes. If you ever anyone play Pokemon Go, you've used Kubernetes. Okay, cool. We've all used Kubernetes. What's really awesome about this is literally the generic solution for what we were talking about before, right? I want to run a lot of my software across hundreds or potentially thousands of machines. This gives me the tools in which I can do that. I want to do all the log aggregation for my processes to put it in one place. Cool, I can do that. I have a new version of this software I want to run. Cool, this gives me that. Right? It's able to build these very generic solutions and hand them to you essentially and let you take advantage of them because of the wonderful abstraction about containers, which is like, that's super, super exciting. And the other lovely thing it really should be worth noting is that it is open source. So that means that you can run it just about anywhere, right? So you want to run a Kubernetes cluster on your own machines, cool, you can do that. If you want to run it on someone like us, we have managed services, ding, marketing, thank you. You can do that. If you want to run it on both, you want to run it on us in other clouds, all those things, you can pick and choose and do all that kind of stuff. If you start on one and you don't like it, then you just pick it up and move it with fairly minor changes, which is really cool. Awesome. All right, so let's actually look at like actually doing this as a thing because it's fun. All right, so we'll start with this bit, which is the matchmaker. I have a really simple matchmaker. It's just HTTP enabled, like just an HTTP matchmaker with some polling. how do we put this on Kubernetes? This is the more quote-unquote traditional workload because it's just a stateless HTTP server with some Redis on the back end. But we'll go through it first because it's pretty straightforward and pretty easy. So Kubernetes is what you commonly refer to as a declarative system, which is also really cool about it. So it's a sort of system where you tell it what to do, and then it basically just works out how to do it, which is very cool. So in this case, we're like, oh, I would like 5 instances, please, of this matchmaking system to be up and running. And you're like, okay, so here's this YAML file. There's a bunch of ways you can talk to Kubernetes. In the sample code I'll show you at the end, or link to at the end, I actually do a lot through the API. But I'm going to show you the YAML file because that's how you do it a lot of the time, and it's also much easier to look at. So here I'm just saying Kubernetes, I would like 5 instances of this thing. This is the image I would like you to send, so that's my matchmaker image. Sweet, tar. Here's some extra information I'd also like to send you. I'd like to send you, like, where is my Redis instance, and I also would like to open some ports. And that's it. I could send this YAML file up, and suddenly I would have 5 instances of this thing running on Kubernetes, which is really, really nice. And the other nice thing is if any of them happen to fall over, it would just restart them, because it's just one of the cool things it does. One thing it also does, you'll notice this little section up on the left here, or my left, your right, is a thing called metadata. This is useful. This is basically a nice way of being able to add arbitrary key value pairs to any containers that are running. We'll see why they're useful in just a sec. But here I basically said, for any matchmaker that's being created, just make sure it just says role and matchmaker server on it, somewhere that I can look it up. So I send this up to Kubernetes, and I'm like, sweet. But there could be, 5 of these running on any of the machines inside my cluster. Who knows where they're running? Maybe one of them dies occasionally because I write bad code. Maybe it shows up somewhere else. I need like a stable IP. How do I connect to these things? I need to be able to talk to them. So strangely enough, Kubernetes has a thing called that. It's a thing called a service. So if I say the word load balancer, people know what I'm talking about. It's okay if you don't. Yes, yes, yes. So if load balancer requests come in, its job is to distribute it across multiple instances of stuff. That's really it. So a service is nice in that it's basically a load balancer, so it gives it a static IP. It can be public or not, if you so desire. But the sweet thing about it is actually this selector thing here. So basically what this service is saying is it's saying, hey, anything that has this role matchmaker server, I would like to expose that to either inside or outside. So you can all hit that service. From there, actually, I can say type load balancer. So if you're running on a cloud provider, that'll set up an actual network load balancer and give you an IP and that kind of stuff. If I don't write type load balancer, it just cuts that off, and then it's just internal to Kubernetes. And you can actually access it through the DNS name that's on the service, which is actually really nice as well. So cool. Why don't I just run this backend and make it happen for you? Yeah, we're just going to build the whole backend for basically this app on my mobile phone, no less, which should be kind of hilarious. What could go wrong? Hopefully everything. No, it's fine. Sweet. So I'm actually going to grab this over here. Thank you. So up the top here, I have this wonderful visualization. It's an open source thing called WeaveScope that's really sweet. Where are we? That basically shows me all the things that are happening inside my cluster, which is nice. So down the bottom, I have, I might actually shrink that just a smidge. Yep. Cool. Actually, I can do this, and then I'll see what I'm doing. So down the bottom, I have some make targets. People here who use make. Oh, you're my people. I love you. Excellent. Make is just a really nice way of automating some steps. I'm just going to deploy Redis. So here you can see me writing kubectl create. This is basically, kubectl is the command line tool to actually send stuff up to Kubernetes and inspect it and do stuff. We'll see how quickly this goes. There we go. Yeah, it goes over my phone quite fine. So this is me creating Redis. I'm going to be a bit hand-wavy about how I create Redis because going into that detail is probably more than I want to do right now. But there's a Redis instance running. People know Redis? Yeah? Cool. I'm going to wait for that to come up. And we can also still do things like, hey, what pods do we got available and stuff. All right, that's actually good. So here what I want to do, all right, so I have that. I want to have the 5 instances we were talking about before with of that matchmaking server. So here you can see I've written kubectl apply. I'm just pushing up that deployment. That dash record is actually just making sure there's an internal record of what's happening here. Now, weavescript's actually kind of neat in that it introspects the network traffic between the different containers that are running, and so it draws lines. And so it becomes really pretty, which is nice. Sweet, so there's my, don't do that. Apparently don't touch my computer. So that's my 5 instances. That's kind of all I had to do, and then I'm actually going to deploy a service as well. So that service is actually going to spin up an actual load balancer, which is kind of cool. I'll let that happen in the background. And I can also do some other cute things. So I'll be like kubectl scale deployment matchmaker. Oh, I hit tab. There we go. We'll say 7, for example. I can do other cute stuff. There's like auto-scaling stuff and whatnot, but this is always fun. There we go, scaled. So I should get a couple more instances showing up in a minute. Go on. There we go. So it's kind of ridiculous the amount of control I have over this infrastructure that runs over, I mean, this is probably, I think this is a 3 or 4 node cluster. But I'm just doing this basically sending up stuff. If I want to have a look at my service. Go on, there it is. Okay, matchmaker. It's got a whole bunch of pods behind it, all that sort of fun stuff. So cool, actually that's it. That's really me firing up my matchmaker. I've actually scaled that down, that's fine. So that's all up and running. Cool, so nothing went wrong so far. Sweet. Excellent, all right. So that was kind of actually the boring stuff. Dedicated game servers, these are totally different. So let's talk about that for a bit. These are totally different because what we saw before was like I put a load balancer and a bunch of stuff. All those web servers have no state. There's nothing in their memory. So they're very different based. I can make 1 million of those and it doesn't make any difference. But dedicated game servers, right, have the whole game state inside their memory. I don't want to put a load balancer in front of them because it's extra latency and that's bad. So how do we handle that, right? So this isn't necessarily something that Kubernetes handles out of the box, but it's stuff that we can definitely use the basic building blocks of Kubernetes to do, make this work, which is kind of cool. So we're going to look at, basically this part here, where we have the 2 players that do a direct connection to that dedicated game server, right? Which is like, ooh, how do we do that? Well, let me tell you. Sweet. So we saw before, like, we saw deployments, we saw services, and that was all cool and great. But especially something actually like deployments. Deployments are kind of like this lovely syntactic sugar, right? They're this lovely construct that sit on top of Kubernetes that work for so many use cases that it's great that it exists. Except the wonderful thing about Kubernetes is actually that it gives you the building blocks, right? So this is what's commonly referred to as a pod. For the sake of this talk, if you just want to hear pod and container and make them the same word, that's totally fine. They're not actually, but it's fine for now. I'll just be hand wavy about it. You can, yeah, it's fine. But it's basically your basic building block in which if you want to run a container, a single container and possibly some more, again, hand wavy, you're able to do so. And again, you have a lot of control over exactly how that happens. So here, this is what I'm doing is I'm actually firing up a dedicated game server. Right. Usually, or in the code that is linked at the end, I actually do this through the API. I've got an API that you can call, but again, YAML, it's easy. So here, I'm able to push this up. So this is saying, okay, kind equals pod. This is the type of thing I want. Another cute little thing that Kubernetes will give you is it'll generate a unique name for you in the cluster. So I let it do that as well, which is because I don't want to do that. That's work. Same as before, I'm just saying, hey, what image do I want? I just want one instance of this image, right? But I don't want you to like manage it or do anything crazy like that. And the real magic trick to this is this one little setting here called host network equals true. Host network is true is because by default, if you start up a container, the container runs on a separate network to like the host, right? So you can't just connect to it unless you do like port forwarding and all sorts of other fun stuff. If you set this to host network equals true, what's lovely is that the network for what's happening inside the container is exactly the same network that is on the host. So basically the machine that it's already running on. The way Docker works behind the scenes is they actually share the Linux kernel, so like there's really no extra overhead there. They actually sit right next to each other, which is super nice. So we can actually do stuff here when we say, okay, host network equals true. It's basically like starting up a process like you would do normally, like you're just like, hey, start my server. And so if I open up a port with this process, which we do, I'm able to connect directly to the machine it's running on. If I know what port it's running on, I can just connect to it. And I have a direct connection. I don't have to worry about any extra hops, which is super nice. Finally, I do some other stuff. I'm like, I set a restart policy of never. So basically, if this game server shuts down or turns off or fails for whatever reason, I'm just like, leave it, it's fine. game players can start again. It's okay, I don't care. I have a lot more control there. And I also do some other nice stuff. Here I'm actually just, this is a fancy way of just writing that name that you generated for it. Can you just pass that through as an environment variable? Because it's useful and we'll use it a little bit later. So this is cool. I can actually send this up, send this YAML file up to Kubernetes. Kubernetes will start one of my dedicated game servers, which is awesome. It'll then take that game server, or actually when I send this up, it'll look at that cluster of machines and be like, oh, where is the most appropriate place for me to put this game server? So basically it does bin packing. This is a terrible joke that I make about when I moved to San Francisco from a large house in Australia, which was lovely, to a very small 2-bedroom place. That was not all my stuff. Yeah, we have more stuff than that. It was like that for 6 months. It was awful. But the cool thing is, again, you don't have to worry about like, hey, I have to pick the appropriate spot. If you want more control over exactly where things are, there's a lot of configuration options. Or if you really want, you can even write your own scheduler and stuff too. But I'm not going to talk about that much. But at a base level, again, Kubernetes is going to make some intelligent decisions about where that server is going to show up inside your cluster. Now, one thing that Kubernetes will not do for you is pick a free port, because it just doesn't do that. So I keep things really simple. I basically loop around a bunch of times and say pick a random port between a range. And if that one works, we'll register against it. That's really it. I don't do anything more than that. I have an API that I set up. Again, all the code's available, wherein I take that environment variable from before, which is the name of that unique name for the pod, what port it ended up starting on, and I send an HTTP post. That's really it. And that works quite nicely because it both tells my system, hey, this thing started, and also what port it's on, so it's ready to go. It's like all sweet. So, okay, that was a bunch of stuff. Let's sort of recap it real quick. So we have 2 players. One connects to the matchmaker. The other one connects to the matchmaker. Cool, we have 2 players. They both want to play the game. Sweet. Those connect to the server manager. So here the server manager is a little piece of code that runs on top of Kubernetes. The server manager talks to the Kubernetes API, right, and says, hey, I would like this pod with this game server in it. Please give me one, please. So that starts up. Dedicated game server starts up inside a container, inside the pod. It then knows to register itself once it's found a port that it can start up on. So it does that. Once it has done that, then the server manager is able to be like, oh, cool, I know what port you start on. I'm able to go back to the Kubernetes API and find out what node you're on. If I know what node you're on, I can find out your IP. So cool, we've got the IP and port combo. We send that back up the pipe to both those players, and they're able to connect directly to that server. Cool, does that seem reasonable? Or reasonably-ish? Sweet. Should we see if it breaks? All right, let's see if this actually works. It was working yesterday. All right, so I need to actually deploy my session manager, my game session manager, so let's do that. There you go, I can see it over there. It's basically exactly the same thing all over again. It's nothing that special. All I'm doing is deploying Redis and a whole bunch of services. The interesting thing here, like this session manager that I wrote, like the game session manager that starts up the game servers, it's about like 500 lines of Go code. It's not really anything that special. It's not anything complicated. You could step through it and read it. There's nothing that special in there. Cool. Whoop. So we can see that all spinning up. There we go. Wait for that to finish. All right, sweet. All right, so I now have a backend for my server, for my game. Let's play the game. Let's see if this works. Awesome. Where are we? No, I want that. Nope, I want that. I lied. That's for later. That's a treat for later. All right. I'm just trying to decide if I want to go. No, I'm going to go this way. All right. So what do I need? So I'm going to. I want to go cheat. I need to get the public IP of where that matchmaker came up. So let me do that off screen so you don't steal it and do weird stuff. Because people are the worst. Cool, I got it. Actually, you're going to see it anyway. That's completely and utterly not useful. All right, so I've got this set up so I can go game, and I've got it set up so I can pass in the IP address. Oh, it's got a space on it, so let's get rid of that so it doesn't break things. All right, running. Okay, thank you, Unity. What's small enough? That looks about right. Cool, I got a little window. Oh, it opened up over here. There we go. Okay, so that started up. I can see that polling in the background. So I'm going to send that to a different window. So I'm going to run this again. So what should happen is it should connect to the matchmaker, pair up, 960 by 720. It should pair up, and once it's paired up and they found a server, then the ball should drop. Let's see if this even is playable over my phone. Okay, cool, starting camera, ball is dropping, excellent. Oops, be good if I actually was on the right screen. Boop, go on, roll. There we go, I have a multiplayer game, yay! Playing over my phone, okay, this is hilarious. Whoops, wrong window. Okay, so that's really it. Like I told you, I make terrible games. They're really bad. Just for fun, I'm gonna kick the ball. Whee! Okay, cool. That's it. That's really the extent of the game, and then it keeps score sometimes. That's it. All right, so sweet. We built the back end for a game, which is awesome. I'm gonna actually kill those, or my CPU is gonna die. Excellent. All right, so in the space of 20-odd minutes or so, I built the back end for a multiplayer game. But let's have some more fun. Let's have some more fun. We can take this kind of to the next level. So why don't we do that? So this is all well and good, but I mean we've all seen game launches that maybe possibly didn't go as well as they could have done because people have run out of resources. So what we'd ideally want to have, at least especially at launch and things like that, we don't want to have a static set of machines, right? Because that limits the top number of players that we can have at any given point in time. In an ideal world, what we want is to make this grow and shrink. Well, at least in a cloud environment, right? So I work for a cloud company. This is something I like to do. If you own all your own machines or you lease your own machines, you might just be like, oh, I'll just set up a really big cluster across all of them and you're fine, which is cool. And totally valid and makes a lot of sense. If you're either bursting into the cloud or running entirely in the cloud, what you want to do is basically just pay for the infrastructure you use. So how can we make it so that this thing autoscales, which would be really, really nice. Now, there's a few interesting things that sort of make this possible, which is quite nice. We're going to talk a bit about scaling up, mainly because that's just the easier problem, but I can talk later with people about scaling down. So the first thing we need to do, if we want to basically be able to say, oh, we have more players who are playing this game, and there's more instances of this server coming up, so let's actually make our cluster bigger, is basically set some constraints. So another nice thing that Kubernetes will do for you is enable you to restrict how much CPU and memory is used by each of the containers, either in a hard way or a soft way, which is also nice as well. But what I'm going to do here is keep things really simple and basically just do restrictions on CPU and basically say, okay, if I have a certain amount of CPU, that's what I'm going to use as my metric for scaling. So when I actually basically sat down, load tested my game, I looked at it and I was like, oh, it uses about, I think I came out to like 0.8 on some, 0.09 on others. So I was like, okay, so it uses about 0.1 of a CPU on the machines that I'm running in the cloud. And again, that can vary depending on your CPUs and that kind of stuff. But it was at about 0.1 of a CPU. So that meant that I could actually also go back to my YAML file and there we go, let me move, and add a limit of 0.1 CPU. Which gives a little bit of breathing room from the load tests I had, but also means as well, like if something really weird happens, then I'm not going to completely interrupt some of the other processes that are happening, which are probably other game servers, right? And those tend to be kind of fickle. What that means then is then I'm able to actually turn around to Kubernetes and introspect how much CPU I have on each machine, because that's something that's available to me through the APIs, and then just kind of do some math. To work out how I want to scale things out. The way I did this was super, super simple, is I just wanted to make sure there was a buffer room for a certain number of servers at every point in time. There's a lot of things you could do. You could do like fancy predictive math and other stuff, but I just wanted to keep it simple. So that basically, as long as that buffer was available, I don't need to add any more servers. But as my player base grows and I'm starting up more servers and they're probably dropping off again as other people disappear, if I go over that buffer at any point in time, I'm going to add another node. That's it. Like really simple strategy for doing this. It's nothing very special. Again, you could do more complicated stuff, but the basics are there. So what I actually end up doing is I wrote a thing called a node scaler. This is all just like little bits. I write everything in Go. The client for Kubernetes for Go is really nice because it's all written in Go. It does basically math is really all it does in a loop. And what it actually does as well is does the math, and then there's nice hooks in there as well, in that not only does it do every 10 seconds, but it'll also do like, oh, I see you've added a game server, so there's an event system that I can hook into, so I know when stuff has started and when stuff has stopped. Again, stuff I don't have to write myself, which is super nice. So here I'm just doing a deployment before, but here I just want one of them because race conditions are bad, and I don't want multiple things messing around with my cluster at any given point in time. And I pass through some environment variables about how I want this to happen. So like how big is my buffer and how much CPU is each game server meant to have. And that's pretty straightforward. So yeah, we've got time. Let's see if I can make my game server bigger. So we're going to deploy this. RS. Sweet. We'll see how readable this is. Should be fine. So I'm going to send up the node scaler. I'm going to go on, there we go. All right, so what I'm going to do here. So again, nice things that Kubernetes gives me. This is basically, ooh, that's not readable. Yeah. That did not help. That did not help at all. Actually, what I can do is this. There we go, that's better. So at the top we can just see the logs that are happening. We can also do this. All right, sweet. So here it's just basically ticking over every 10 seconds. It's like, how much buffer do I have? How much buffer do I need? I'm actually going to get the service name as well. Actually, I've got it. Yeah. So I'm going to fake a bunch of joining clients, and we'll see things go up. So that's fine. That's right. Thank you. So you'll notice up here, where are we? Available 36, buffer of 30. I'm just going to fake some ads. Cool. There we go. Available 35. It'll stop another one. Cool. It's just starting up servers in the back end. We can actually look at the actual visualization in a minute. Cool. So that's going. I will also say kubectl get node. So basically have a look. All right. So what nodes do we have available to us? Here we go. So we've got here apps and also game servers. So actually, I'll talk about that in a minute. But we've got 4 instances there. So let's just keep going. Ready for time? Perfect. This is the boring bit. I just have to create servers. I should really make this a smaller number. I did something silly. I moved my cluster over to Australia, but I didn't move my registry, my container registry from the US, so it's pulling stuff over the Pacific, which was silly. All right, so the next one should do it. All right, so we're available 30. So now we'll drop down to 29. Cool. Now it's like, oh, there's 29 available. Available 29. Yep, so we're going to have to increase it by 1. All right, so now it's going to go off and do that. So while it's doing that, I'm going to distract you with other things, because it takes a few minutes to come up. So you may notice also here that if we look at the series of nodes, so this is all the actual virtual machines that are running. Some of them are called apps, and one of them is called game servers. So one of the nice things that Kubernetes also gives you is it enables you to set up heterogeneous clusters. So basically groups of machines that all have different aspects. So maybe different resources, maybe they have bigger CPUs, GPUs, whatever you want to add. So basically I've split this up as well so that I have a series of machines that have role equal apps as a label attached to them, where that's where all my apps go. And I just want my apps to run on there. I do that for 2 reasons, one of which is the machines that run my apps don't need very many CPUs. They don't do a whole lot, so I make them smaller machines, so I pay less, which is nice. Also, if I ever do anything weird with any of my apps, it means it has no impact at all on my dedicated game service, which is a nice bit of security. Well, not necessarily security, but just nice resource management. And it means the very critical things in my dedicated game servers are super protected by basically not being on the same machines. And then I have a bunch called role equals game server, where I have, this instance, I've got 4 CPU machines. I'd probably actually do that with 16 or 32, or even maybe more, depending on your needs, where literally the only thing that runs on there is dedicated game servers. So I have a huge amount of control. I do this through, strangely enough, on my pod spec, everything called node selector, where I can basically specify where things go. There's about 3 different ways you can actually do this, each with different kind of trade-offs. So it gives you a lot of capabilities that way. All right, so while I was confusing you with other things, let's see if that's worked. Nodes, come on, give me 5 nodes, go and do it for me. Come on. There we go. All right, sweet, now I have 2 game server nodes. Yay! So I've autoscaled up. There's other cool stuff I can do for scaling down as well. I can coordinate nodes, so I can tell them, hey, don't schedule stuff here. I can do all other stuff as well, so scaling down is not exactly too bad either. All right. So wrap things up. So what did we talk about today? With a bunch of open source software. So what we talked about was we take our dedicated game server. In this instance, it's a Unity game server. We stick it inside a container. Containers are awesome because, again, that fantastic abstraction they give us, because it means that we can treat them just like any other types of piece of software. And once they're in a container, we can use a solution like Kubernetes, in this particular instance, to run them at scale. So we can go up to 5,000 nodes in a Kubernetes cluster right now. There are also facilities built in that I'm mucking around with. So there's what used to be called federation is now kind of being called multi-cluster, and it's still called federation. I don't know. The names change. Wherein you could basically control multiples of these around the world in a nice way. But again, the API is also available, so you can do this. So you can run on multiple clusters around the world and do all sorts of neat stuff with that. From here, we actually touched on a bunch of these. I do this talk a lot, so sometimes it's more or less. We talked about a little bit like scaling down with coordinating, that kind of stuff. There's like, we talked about a little bit this thing called pod affinity to avoid fragmentation, so making sure like your game servers all stay on the same machines. So as they shut down, it becomes easier to scale down because you don't have like Swiss cheese all over the place. We could do other fun stuff like warm pools of game servers, which just becomes like just more management, but is entirely possible. Using math to predict cluster size, and so much more. The APIs are so powerful, it's kind of crazy and amazing. We definitely have time for questions, but I will reiterate that my cards are right there, so please feel free to grab some, as well as Kubernetes stickers and really cute Gopher Kubernetes stickers that I don't have as many of. All the code is available at that GitHub URL up there, along with links to a series of blog posts where I've gone into much more detail about this stuff. It's a 5-part series, and I've written the first 3. But definitely there. If you're interested in Kubernetes, kubernetes.io is a great place to start. If you haven't touched Docker at all, the Docker tutorials are actually really, really good. If you want to try Kubernetes and you're like, I don't know if this is a good fit, I promise you this isn't a sales pitch, because I don't care if you stay on GCP, but the getting started experience for Kubernetes on GCP is super nice. It's a free trial. You go in, you're like, I want a 3-node cluster, you push a button, it starts. Then you can basically work out if like the platform is good enough for you, and then if you want to take it somewhere else, you can decide whether A, is another place better for you, or if you want to run it yourself, which involves some pain, but is documented and stuff, you can do that as well. Finally, I'd probably be really remiss. I do a podcast if I didn't mention it, and there are more stickers down there. We've had on the podcast for gaming stuff, so we've had Edward Wu, Director of Engineering for Pokemon Go. He came on the podcast. We've had some people from Pocket Gems. We've had a smaller studio, Guardian Kingdoms, all talking about how they run their infrastructure in the cloud, so it was super interesting. We had people from Humble Bundle come on it, which was just weird and coincidental, and one of those random things that kind of happened but was awesome at the same time. And as of Thursday, we'll be releasing our 100th episode, which was just kind of cool. We interviewed Vint Cerf, who kind of created the internet, and by kind of I mean like he co-founded the actual internet. It was amazing. Anyway, I digress. We have literally 5 minutes for questions, so thank you for, if you have to run, that's okay, but yeah, thank you for taking the time, and I will open the floor up to questions. I can relax now. Nothing, which means I made no sense at all or complete sense. Everyone laughs, but that doesn't tell me one way or the other. Oh, yeah, and I can tell, like I'm presenting, so my American accent's coming out, because that's what I'm used to using now these days. Nothing? Nobody? Nada? Oh, there we go.
I'm asking because there's no other questions. So for me, basically, I'm all new to this. If
Yep.
I want to, from start to finish, learn as much as possible, totally beginner.
So totally beginner in like you've never touched like
Yeah.
VMs or anything?
Exactly. What resources would you recommend?
Ooh, that's fun. That's hilarious. I would start down the general web pathway first.
Yeah.
So pick a language, I don't care which one, and just get like a website up, like something basic and simple, like something that just says hello world in HTTP, and go through any one of those number of tutorials. If you want to do it on us, we've got a bunch of quick start guides for most of the languages we support. So you could do that, but there's a variety of options out there. I would start there and just be like, oh, I put something on a VM and it returns hello world, sweet. And that's like a starting point. And I would go there. Yeah, this is definitely a lot if you're like, I know nothing, which is fine, but it's good to know that it exists in case you need something like this later on. But I would probably start somewhere there. If you're really interested in this stuff and you want to get like super deep on it, a lot of people probably already know these resources, but it's fine. Gaffer on Games, if you've read any of his stuff about network physics and basically how to do that kind of stuff for multiplayer games, it's awesome. I can't recommend that enough. He actually links to a book in there too about, I think it's either Indiegogo or Kickstarter, or it may have come out. He links to a game, it's called MOGS, Multiplayer Online Games, Deploying and Developing Multiplayer and Online Games. Yes, it's IT Hair, I want to say. That's quite good. I've got a bunch of other resources if you need it at all. Read my blog posts. They might be useful as well. Listen to the podcast. Yes?
Apologies if it was clear enough, but each instance of the game server,
Yep.
you would have a separate executable for each one of the kind of rooms, like instance of the game server. Is that the idea?
So in this instance of the game I made here is like a session-based game. So like 2 people play and then the server dies, and then 2 people play and the server dies, and that's it, right? So I'd have one instance for each 2 players that was coming in. Are you talking like more of like an MMO type context?
Yeah, so the idea, I guess, you would have to run, you'd probably be running multiple processes, like
Yeah.
instances of that game server per machine.
Yeah. So you could do this for MMO type stuff, but like your strategy for how you would start and stop them would just be very different. Because yeah, you'd probably have a stable set, and then like people come in and go out. Or you could even do cute things like as you know your area of space, like you only start them up for as people get close to things, and then you have your overlapping grids, and you could do cute stuff that way. And as they fill up, then you add more as people do stuff and that kind of stuff. And then you could do it more on a geological, like basically by a spatial recognition and where people are at. But this, yeah, the basic tech's the same. It's just how you spin it up and spin them down really just depends. Yep. Yeah, you'll find most dedicated game servers are single-threaded. Like these days, it's starting to shift a little bit. But yeah. Faster CPU's better, generally with this stuff. Go for it.
So you connect to the master server using HTTP, right? But the game servers, they go through like some TCP UDP connection. Is that right?
Yeah, so the matchmaker, yeah, so that connects directly to a service, just a load balancer. And I was just doing HTTP because it's easy and I don't feel like doing socket stuff. And then yeah, it's a UDP traffic actually. So I was using, I don't know if you saw at the beginning, the Unity high-level API. That handles the state sync over UDP. It's okay. It's good for prototyping, really.
Can you deal with like, do you run into issues like, NAT punch through or?
So that, you don't need NAT punch through here, right? That's one of the benefits of having an authoritative server because you're not going peer-to-peer. So I don't have to go out through a NAT either over the internet back into somebody's NAT and then go back around again. So I don't have those issues. It's one of the benefits of having an authoritative server as well as like some cheating applications. But you have to run your own service.
Yeah, so Unity,
That's your trade-offs.
Unity's structure is actually
Yes.
SFTP, and this is
So if you follow the tutorials, then yes, you're 100% correct. The way it will set up their multiplayer stuff is peer-to-peer, but you can turn it into an authoritative server. It's not impossible. They just don't document it very well. You can look at my code.
yeah, that makes sense.
And I can talk about how you want to do that later. It's not bad. Like it's not going to be as efficient as writing it from hand or something like that, but it works. It's not too bad. If I was going to do like a proper game like this, I'd probably lean more on Unreal because that's what it was kind of built for. And they build games on it that they actually, you know, like Paragon and stuff like that. It's all built with Unreal. So they do that. But I know people that do run Unreal as a dedicated server. I'm out of time. Thank you so much again for spending time with me. Again, stickers, cards, etc. Yada, yada, yada. Thank you.